Hello, guys. So we are starting our new topic, transaction. Okay. So what is transaction? Okay. And states of transaction. All these things we will discuss from now. Okay. So first of all, understand what is transaction. Suppose, okay, you and your friend you are doing a transaction in bank. Okay, same in this is okay, this transaction is same as your bank transaction. Okay, so what happens, suppose in your account, okay, there is $100. Okay, and in your friend account there is $10. Okay, and now you want to send um, some money from your account to your friend, okay, account. So what you will do, you will do only one thing. What? Just send money. Suppose $50, you have sent $50 from your account to your friend account. But now what happens, in your account there is $100. But now when you have sent the $50 will return from your account, and 100 minus 50. Okay, initially in your account there is $100, but after doing transaction the $50 will be what, subtracted from your account. Okay, and send it to your friend, and your friend's account there is only $10, and we have sent $50, so this will be added in your friend's account. Okay, so that's a process of transition. So that's a transition. But what transition will do, suppose there is a system failure. Okay, so what you will do, suppose you have sent $50 from your account, and at the time when the amount will get into the your friend's account, at the previous time the amount will be deducted from your account but not reached at the destination, means your friends. So this will leave us a redundancy. Okay, how redundancy? So you have sent but your friend doesn't get that amount. Okay, so you have lost $50. So now understand, the two main issues to deal with transition is that one is failures of various kind. Okay, such as hardware. Suppose our hardware is not working, so that will be a problem. System crashes. Suppose OS is not responding, not doing its task. So that's all about the transition. So now we read the two lines. A transition is a unit of program execution that accesses and possibly update various data items. Okay, so understand first, this is small transitions. Okay, t1 suppose. Okay, so now what happened, first of all, read a. Okay, read, and a is what, a is the account of the first person, means you, means first in our transition this is a sixth step. So first it reads the balance in our account A. Okay, and we have sent $50. So what it will do, it will update our transaction. So A has supposed $100, 100, and it minus 50, and this $50 will update into A. Okay, now write A, that means this will write into our database. Okay, means in our database we have done a transaction, but it write into the database. First in our database there is $100 written, but after performing this operation, now in our database only $50 is remaining. So write a another, and at the receiver side, destination side, it again read b the our friend's account balance, and it will add the $50 in our friend's account. Okay, and update into the database. So that's a short code to understand the transaction. Okay, so that's all about the transactions. Okay, so now I have discussed these two reasons why the transaction used, it has to deal with two things, failures of various kind I have discussed, and concurrent execution of multiple transactions. Now what is concurrent, means in our system there are multiple transactions parallelly executed. Okay, so that's the responsibility of transaction. Okay, now these are the properties of a transactions. Okay, required properties we will discuss in another separate video, that's called asset properties. Okay, so asset properties we will discuss in later, but now we are getting some small idea. Okay, if the transaction fails after step third and before step 6, money will be lost, leading to an inconsistent database. This is the short code. Okay, so read A in our A, suppose they are $100 and we have subtract $50, write A. Okay, and at that point, okay, our system get crashed. Okay, so write A means in our database, in the A's account balance we have written 50 and initially it has 100, so 50 loss, and these three steps due to some reason not executed. So due to this our system get inconsistent because A lost $50, okay, and B not received that money because at the third step means third step our system get failed due to this. Okay, the system should ensure the update of a partially executed transaction are not reflected in the database. Okay, that means atomicity. So write A is actually not writing in the database. Okay, it is writing in the small buffer, like in our main memory. It is writing in the main memory after committing the transaction, then it will be write into the our database. So actually it is writing in the buffer what it is saying. Okay, all partially executed. This is partially executed, not completed transaction, only partially updated. So it will be only written in the our buffer. After committing the transaction we will write it to the our database. Second, consistent. Okay, so after consistent, first we understand the isolation, then we will come to consistent. So isolation, if between step 3 and 6 of the fund transfer transaction, another transaction T2 is allowed to access the partially updated database, it will be inconsistent. The sum A plus B will be less than it should be. So it is saying in our system we have to maintain concurrency also because it has another advantages. So in our system T1 is running, at the same time T2 is also in there in the system. So at the time of the third step, these three steps run by the T1. At the fourth step in the middle, this is space empty. At the time the T2 is also read B and print AB. Okay, so this will ensure the system will be inconsistent. Why? Because A 50, so A is updated value 50 and B has updated value worth something $10. So that's 50 plus 10, it's 60. But actually if the 50 amount which is deducted from the A's is not received at the B, okay, so initially suppose it is 100 and it is 10, so total is 110, but due to this write A, okay, and we have not done these three instruction at that time, it is 50 minus means initially 100 minus 50 equals to 50, A equals to 50 and B is 10, so 50 plus 10 equals 60. That's what it is saying, A plus B. So our database is inconsistent because it has to be 110 but it has what, 60. Okay, isolation means all transactions are thinking that it is alone in the system, only it is there, not any other transaction. That means serially executing. Isolation can be ensured typically by running serially. That is, first transaction is running, after completing this transaction second transaction will be running. So that's what. Okay, however executing multiple transactions concurrent has significant benefits. So I think you understand the full concept now. We are not understanding the full concept of transaction. In the another tutorial we will learn about asset properties. Okay, so at that time we will complete the our